Okay, so now we're going to talk about multiplying rational expressions. This is really fun because you've already done this before if you've multiplied fractions, okay? The rules don't change when we're dealing with rational expressions. So if we have a over b times c over d, we simply multiply across. So we take a times c, and then we take b times d on the bottom. So we have ac over bd, okay? Then we would simplify if it's possible. In this case, we're not sure because we don't know if a and c and b and d have any common factors. So we want to simplify if possible. Okay, so here's an example. If we had 5x squared over 2xy squared times 6xy cubed over 10y. So again, we want to multiply across. We have 5 times 6, that's 30. X squared times x, remember when we're multiplying we add the exponents, so that's x cubed. No y terms here and a y cubed, so that's y cubed on the top. Then on the bottom we have 2 times 10, that's 20. X, and no x terms, so just x, and then y squared times y. We're going to add those exponents, so that's y cubed. Now right away you can see that we have a y cubed on the top, a y cubed on the bottom. Those cancel out because they are the same. Okay, then we have to look at, are there any other factors we can cancel out? So if we look at 30 and 20, if we factor 30 completely, that is the same as 2 times 3 times 5. Okay, you can make a factor tree if you need to. And then 20 factored completely is, let's see, 2 times 2 times 5. Okay? And then we have x cubed, so that's 3 x's, x times x times x. And then we have another x on the bottom. Okay, what cancels out? We've got a 2 on the top and the bottom, a 5 on the top and the bottom, and an x on the top and the bottom. So we are left with 3x squared over 2. And that's our simplified answer. Okay, so let's outline the steps for multiplying rational expressions. We're going to write all the polynomials in standard form. You'll see why this is important later. Factor our numerator and the denominator. Multiply and cross, leave it in factored form. Cross out any common factors, and then finally simplify our final answer. So let's do some more examples. For example, we have 2x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Okay, so let's factor everything first. So this is, okay, if we have 2x squared minus 10x, it has they have a common factor of both 2 and x. So that's 2x. What's left over? 2x times x gives us 2x squared, and then 2x times negative 5 gives us negative 10x. So that's fully factored on the top. On the bottom here, we've got a difference of 2 squares. Okay, so this is x squared, and then 25 is actually 5 squared. So our a is x, and our b is 5. So that becomes x minus 5 times x plus 5. So that's our first term fully factored. Then our second term, right here, x plus 3 can't be factored any further, so that's factored already, and then 2x squared is already factored as well. Remember that 2x squared is really 2 times x, okay? So if you need to, you can write yourself a little note there. Now we want to multiply across. Before we do that, actually, if you see that you can cancel anything right away, like an x minus 5 here and an x minus 5, go ahead and do that, okay? It doesn't matter if you do it now or in the next step, you're still going to get the same answer. So you're making it easier for yourself, less writing if you cancel it now. Now we're going to multiply across. So I have 2x times x plus 3. On the denominator, I have x plus 5 Okay, and then a 2x squared, or 2x times x. So actually I'm going to write my x plus 5 down here. And then I have 2x times x, or 2x squared. Now notice we have a 2x on the top, 2x on the bottom. Those cancel out. And then we have an x plus 3 over x plus 5 times x. So none of those are common factors, so we are left with x plus 3 over x times x plus 5. And that's our final answer. Okay, so let's look at the next one. We have x plus 5 over x squared minus 1 times this trinomial right here, which happens to be a perfect square trinomial. I know that because this is 1 squared, and this is 2 times 1. So we have that pattern of a squared plus 2ab plus b squared, where a is x and b is 1. Okay? So x plus 5 up here, that's not factorable any further, so we keep it. X squared minus 1, that's a difference of 2 squares again. So we have x minus 1 times x plus 1. And then this perfect square trinomial again, that's going to be x plus 1, the quantity squared. Okay, you can either write it as x plus 1 squared, or you can write it as x plus 1 times x plus 1. Okay, remember, if there's nothing in the denominator, that's like having a denominator of 1. So you can write that 1 to give yourself a reminder. Our next step, we want to multiply across. So on the top, we have x plus 5 times x plus 1 times x plus 1. Don't worry about multiplying them out yet, okay? Because we want to cancel anything out if it's possible. Then on the bottom, we have x minus 1 times x plus 1. Now we want to look for what can we cancel out. We have an x plus 1 both in the top and the bottom. So those both cancel out. Then we're left with x plus 5 times x plus 1 over x minus 1. And that's our final answer. Okay, don't worry about multiplying this x plus 5 times the x plus 1. Don't worry about multiplying those. Your book leaves most of your answers in this form. So it's okay to leave it in the factored form at the end. So now let's move on to dividing rational expressions. Okay, this is the same rules as dividing regular fractions. Okay, so we want to, if we've got a division, let's see, if we're dividing here, we have a over b divided by c over d. Remember, this is the same as a over b times the reciprocal of c over d. So you just take that fraction and you flip it. So it's actually a over b times d over c. Then we can treat it just like a regular multiplication problem and multiply across. So we take a times d, which is ad, and then b times c, which is bc. And that's our final answer. Okay, so here's the simplest example we could possibly think of, is if we have two fractions like 2/5 divided by 7/3. Okay, that's the same as 2/5 times 3/7. Okay, and then we take 2 times 3 over 5 times 7. Notice they don't have any common factors, so we can't simplify. If they did have common factors, we'd cross them out right then. And then we can multiply this. So this is 6 times 35, or 6 over 35, and that's our final answer. Okay. It gets a little more complicated when we're dealing with rational expressions or polynomials here, but the rules stay the same. So we keep 7 over x plus 1, keep it as it is. Okay. Then we're going to multiply by this rational expression flipped, so that is 2x minus 3 over x plus 2. Notice each of these is already factored. Okay, so we cannot simplify these any further because they don't have any factors in common. So we're going to simply multiply across. So we have 7 times 2x minus 3 over x plus 1 times x plus 2. And that's our final answer. Again, your book is going to leave the answers like this. They don't have you FOIL them out, so that's actually less work for you. Yay! Okay, so to review the steps, we want to change it to a multiplication problem, factor if possible, multiply across, so numerators with numerators, denominators with denominators, cross out any common factors if possible, and then simplify if possible. So here are some examples. Let's look at these problems. So we want to start off. Let's review the steps. Change to a multiplication. So we have 4x over 5x minus 20 times, and we're going to flip this second one, x squared minus 6x plus 8 over x squared minus 2x. So we flip the second one. Then we want to factor everything if possible, and in this case it is possible. 4x is already factored. 5x minus 20. 5 and 20 both have a common factor of 5. So we have x minus 4 left over. Then we have a trinomial here. Okay, so we're looking for factors of 8 that add up to negative 6. So that is negative 4 and negative 2. And then on the bottom here, a factor of x squared and 2x. That's going to be x. Left over, we have x minus 2. Notice we can cancel these x minus 2's, or we can cancel those right away. Okay. Now we're going to multiply across, so we have 4x times x minus 4 over 5. And then we've got an x here. I like to keep those out front. And then x minus 4. Okay, on the top and the bottom we've got x minus 4. Those cancel out. On the top and the bottom we have x, and then 4 and 5 don't have any common factors. So this was actually just a very complicated way of saying the fraction 4/5. Okay, the last example here. So we've got another division, and this is a 6x. I don't know why my computer is not showing it. Okay, remember if there's nothing on the denominator, that's going to be a 1, and that's going to help us when we flip it. So let's rewrite this. We have 2x squared plus 3x minus 5 over 6x, and then we're going to multiply that by this flipped. So it's 1 over 2x squared plus 5x. Okay? Now that we've done that, we can factor everything. So we're looking for, if we have, remember we've got a coefficient of 2 here, so we have to multiply those together. We're looking for factors of negative 10 that add up to positive 3. Okay, so that would be negative 2 and positive 5. So we want to rewrite that, and we can actually, it's probably best if we do this off to the side. So we have 2x squared plus 3x minus 5. So let's rewrite it. 2x squared minus 2x plus 5x minus 5. Okay, then we want to treat it as two separate problems. Find the common factor here. So that is, let's see, 2x. We have x minus 1 left over. And then here, common factor is 5, x minus 1 left over. So our factors up here are x minus 1 and 2x plus 5 over 6x. And then we're going to multiply that by 1 over, we have a common factor of x, so we bring that out front, and then we have 2x plus 5 left over. Okay. Now we're going to multiply across, so we have x minus 1, 2x plus 5, over 6x times x times 2x plus 5. Okay, these 2x plus 5's cancel out, so we're left with x minus 1 over 6, and then x times x, you remember, is x squared. And that's our final answer.